Hello everyone, welcome back to my channel Smart Engineer. Today we are going to discuss on the topic that is the cellular concept systems and design fundamentals. In that we will see trunking and grade of service, improving the coverage and capacity in cellular system, that is in cell splitting, cell sectoring, repeaters, micro cell zone concept, etc. So what is trunking? Trunking is a method for a system to provide network access to many clients by sharing a set of lines or frequencies instead of providing them individually. This is analogous to the structure of a tree with one trunk and many branches. Examples of this include telephone system and very high frequency radios commonly used by the police agencies. A trunk is a single transmission channel between 2 points, each point being either the switching center or the node. Cellular radio systems rely on trunking to accommodate a large number of users in a limited radio spectrum. The concept of trunking allows a large number of users to share the relatively small number of channels in a cell by providing access to each other. On the demand from a pool of variable channels, the user is blocked in a trunk radio system when particular user requests service and all the radio channels are already in use. There are two types of trunk systems which are commonly used. First type offers no queuing for call request, that is lost call cleared. The second kind is one which is queue in provided to hold calls which are blocked, that is lost call delayed. First one is the lost call cleared and second one is the lost call delayed. There are some key definitions used in the cellular systems, that is setup time, blocked call, holding time, request rate, traffic intensity and load. We will see one by one. What is setup time? The time required to allocate a radio channel to a requesting user is called setup time. Blocked call, a call which cannot be completed at the time of request due to congestion, that is called blocked call. Holding time, so average during of a typical call denoted by H in seconds is a holding time. What is request rate? The average number of calls requests per unit time is called request rate. What is traffic intensity? Which is measure of channel time utilization or the average channel occupancy measured in erlangs. Dimensionless quantity denoted by A. What is load? Traffic intensity across the entire TRS is called load. Now, what is grade of service? The grade of service is a measure of the ability of a user to access a trunked system during the busiest hour. The busy hour is based upon customer demand at the busiest hour during a week, month or year. Grade of service is the probability of a call in a circuit group being blocked or delayed for more than specific interval. The grade of service is a benchmark used to define the desired performance of a particular trunk system. GOS is typically given a likelihood that a call is blocked or likelihood is call experience in a delay greater than a certain queuing time. To meet specific GOS, the maximum required capacity of the system must be estimated and the proper number of channels must be allocated for the system. So the next is trunking efficiency. Trunking efficiency is a measure of the number of users which can be offered a particular grade of service with a particular configuration of fixed channels. The way in which channels are grouped can substantially alter the number of users handled by a trunked system. Next one is the improving coverage and capacity in cellular systems. The demand for wireless service is increasing. Therefore, the number of channels assigned to a cell eventually becomes insufficient to support the required number of users. Hence, cellular design techniques are needed to provide more channels per unit coverage area. Following are the techniques used to improve coverage and capacity in cellular systems. First is the cell splitting, second one is the cell sectoring, third one is the repeaters for range extension, and fourth one is the micro zone concept. We will see one by one. First one is the cell splitting. Cell splitting is the process of subdividing a congested cell into smaller cells called each with its own base station and corresponding reduction in antenna and transmitter power. Cell splitting increases the capacity of a cellular system since it increases the number of times that channels are reused. This is achieved by defining and installing new cells which have a smaller radius than the original cells, that is microcells. The increased number of cells would increase the number of clusters, which is turn would increase the number of channels reused and capacity. As the size of cell is reduced, the same frequencies can be utilized in more cells, which is in turn increases subscribers accommodate on the systems. The concept of cell splitting can further be applied to the cells as well. That is, the split up cells can be further be split into number of smaller cells to improve the efficiency of the base station even more. This is the diagram of cell splitting. Here the master cells which have been split into smaller cells are known as macro cells. The split up cells are known as microcells. The innermost cells split up by splitting the microcells are known as picocells. There are some advantages of these cells, which is to increase in system capacity, reduction in antenna height, and reduction in transmission power. There are also disadvantages of the system is handoff and unit area increases. Umbrella cell for high velocity traffic may be needed and more base stations needed. This is the complicated design process. Next one is the cell sectoring. Sectorization consists of dividing an omnidirectional, that is 360-degree view from the cell site into non-overlapping slices called sectors. When combined sectors provide the same coverage, but they are considered to be separate cells, also considered as one of easy and inexpensive capacity increasing solution. In cellular telephone system, co-channel interference can be decreased by replacing a single omnidirectional antenna, where several directional antennas, each radiating within a smaller area. Cell channels broken down into stored groups and CCI reduces because only some of neighboring channels radiate energy in direction of main cell. There are only two co-channel cells with interfere if all are using 120-degree, where only one channel cell would be interfere using 60-degree sectoring. Figure shows the diagram of cell sectoring. Also, there are some problems with sectoring, which increases the number of antennas at base station and decrease in trunking efficiency due to sectoring, increases number of handoffs, and this is the good news for the sectoring is many modern base stations support sectoring and related handoff without help of MSC. Next one is the microcell zone concept. A microcell is a cell in which mobile phone network served by a low power cellular base station, that is called tower. Covering a limited area, the aim of creating microcell is increasing the capacity of the cellular network. In the area where population is high, typically the range of the microcell is less than 2 km wide, whereas the standard base stations may have ranges up to 35 km. By the use of sectorization technique, we can increase the system performance, that is quality of the signal. But side by side there will be a large increment of handoffs which results in the increment of load on the switching and control link elements of the mobile system. The microcell zone concept is related to share the same radio equipment by different microcells. This results in reduction of cluster size and hence the increase in system capacity. This is the figure of microcell concept. Next one is the repeaters for range extension. A repeater is an electronic device that receives the signal and transmits it at a higher level or high power so that the signal can cover long distances. A cellular repeater in the cell industry is a device used for boosting the cell phone reception to the local area by the usage of reception antenna and a signal amplifier and internal rebroadcast antenna. The use of repeater in cellular mobile communication system is for extending the range of reception of the receiver. Especially the repeater is used when it is hard for the transmitter signal to reach the receiver set. Repeaters are bidirectional in nature and simultaneously send signals to a receive signals from serving base station. Repeaters are being widely used to provide coverage into and around buildings where coverage has been traditionally weak. The market for cellular repeaters is expected to grow rapidly over the coming years due to the combination of the poor networks coverage in some areas and the large scale departure from landline systems. Thank you.